Okay. You can see there's only 3 bullet points. We are looking at solving linear equations, which you should already know how to do. Then we are looking at word problems and finding the zeros of a linear function. We will complete this in the course of 2 days. I have a stop sign to appear when I'm ready to stop. Look at the first slide. This slide has information you should already know. There's really nothing that we need to add to it. If we look at it, refreshing your memory, an equation means the left equals the right equals the left. If you're solving, whatever you do to one side, you have to do to the other. If you recall from chapter R, you have to clean up the equation first. See if there's any like terms to be combined on the same sides, or if there's anything that needs to be distributed, you do that, then you start to solve. So you simplify first, then you solve it. After you solve it, you can take your answer and plug it back into the function or to the equation to verify if it's true or false. To solve an equation, find an equivalent equation, and variable is isolated. That's where you're just getting it by itself. So let's go to the next slide, and let's dive right into practicing solving equations. I copied the box from the textbook to remind you that whatever you add to one side, you have to add to the other. Whatever you multiply with on one side, you have to multiply with on the other. It is an equation. Y'all know those, those scales of justice. You know what I'm talking about, right? And they, depending on how much weight is in them, they either balance out or one side can be heavier than the other. With an equation, it is exactly like this concept. So if I come over to one side of the equation and I add 1, it's off balance until you go to the other side and add 1 as well. So keep the visual that whatever you do to one side, you've got to do to the other. If you tend to make simple mistakes or struggle with where to start, it would help to draw a vertical line down the equal sign to help you compartmentalize your left from your right, so you don't accidentally repeat an operation on the same side. Red means wrong here, like for instance saying add 1 there and add 1 there. Those are on the same side, so that's adding 2 to the left, which is not going to help you at all. So that's what I mean by making sure you stay on the same side, or opposite sides. Okay, we're going to solve 3/4 x minus 1 equals 7/5. The leveling up aspect of this, you might think, why are we solving equations? It's college class. Well, the numbers are ugly. Can you handle it? Can you take the heat with ugly numbers? That's what we're doing here. So we want to get x by itself. You need to get the term that has x, which would be 3/4 x, by itself. We're going to add the 1 to the right. So the 3/4 x comes down. Please embrace fractions. You can totally type this in your calculator. I'm not expecting you to do these in your head, but I would love for you to reach that leveled up point of where you can deal with fractions in your head eventually. Use the calculator to check your answer. Maybe do it in your head, but then go to the calculator and check it. If you are looking at your calculator, we're going to add 1 to the right. If I'm adding 1 to a fraction, I need the 1 to be a fraction, right? And I'm going to look at the denominator. This is where I'm trying to help you level up in your own mind. We're going to check it in the calculator. I'm going to look at the denominator. It's a 5. So I need my 1 to be, change it 5/5, right? It still needs to be a 1. So when I say add 5/5, that comes from me thinking to myself, I'm adding 1 to it, and now I can do it in my head. You add the numerators, so it's 12, and the denominators stay the same. It's like the last name. So this is 12 over 5. Now let me show you how to check it in your calculator. 7/5, it's a lot easier if you will use alpha y equals. There is a fraction math print button right there, N over D. And now you can actually see your fractions. And in this case, we can just write that we're adding 1. We don't have to convert it here. And it's going to, because the fraction 7/5 was entered as a fraction, it will produce it as a fraction. Okay? Now, look at the equation that you have here. You have 3/4 x equals 12/5. What's in the way of x being by itself? 3/4 is in the way. There are 2 ways to handle this. You can do it in an a la carte fashion, which means 1 at a time. You could multiply both sides by 4 to get the fraction in the way. Then you would divide both sides by 3. You can do that. But leveling up would be recognizing this fraction here has got to go, and the only way to get rid of a fraction is to multiply by its reciprocal, because then you end up with a numerator and a denominator that match, which equates to the number 1. Now, whatever you do to one side, you got to do to the other. Please, please, please remember, when you're multiplying fractions, you just multiply straight across. So this is going to multiply straight across. This goes away as 12 over 12. So we end up with 48 over 15. Now, in the calculator, if you will enter the fractions that are multiplying, it will reduce it for you. You've got 12/5 times 4/3. And it reduces to 16 over 5. Which is the answer. If you were to go to your calculator and type the left side in, 3/4 times, oh, thank you. Let me try again. Type it in correctly. 3/4 times, it's from when that girl hit me like 4 years ago. Awesome. Well, y'all, I'm not kidding. Like, somehow the speaker hits me, the girl ran into me. That was, I think, a year later. It's just, I'm always in the wrong spot. Minus. It's -1. Or times, what did we get? 16 over 5. So look what I'm typing. What I just typed in the calculator was just the left-hand side. I typed the left-hand side, and in place of x, I put my answer. And I verified that I got the right-hand side. So that simple little 10-second check is reassuring yourself that you're doing it right. Let's go to another one. A little more complicated this time. You cannot solve that until you clean it up, right? You have to simplify it down to where there's no like terms left on the left, and there's no like terms left on the right. That probably sounds really confusing, but I'm talking about on the sides of the equal sign. You need to distribute the 2. You need to distribute this -3. The 8 just comes down. Then you've got like terms on the right that need to combine. Now we have no like terms, now it's time to start moving things to opposite sides, right? This is the process of solving. You have an x term on each side, so you have the freedom of choice to decide which one you want to move. I personally move the one with the smaller coefficient, or in this case, since they're both negative, when I go to add the 3x to the left, it's going to be a negative 3, and I like the x to be on the left. It doesn't matter. Y'all decide how you want to proceed. I'm going to add 3x to that one to make it disappear, so it's gone. Then I'm going to come right here and add 3x to this one to balance it out. Now, because my x is on the left, I got to subtract a 10 to the right. And that would be what? Negative 8. When I go to divide 3, the negative 3, it is not pretty, so we are going to leave it as a fraction because that is more accurate. But it is a negative over a negative, which means it's going to actually be positive. Remember, you're doing something you've been doing for years in math. It's just now the numbers are ugly. To see, can you hang? Don't flip yet. Go back. We're going to add something to this. What if you wanted to check this in a faster way? Enter calculator. You can. I'm going to show you how to do it, and then I'm going to write the steps, and you can copy it down. Because you have an equation, the left equals the right equals the left, right? Yes? Okay. You can go to y equals. We obviously want to clear out the crap we did yesterday because otherwise the stat plot's going to be in our picture and that's going to confuse things. The easiest way to do this is arrow up to the plot that's on and just hit enter and it's going to turn it off. So the data is still in there from yesterday, which doesn't matter, but it's not going to show it when we graph. I'm going to clear that. So here's a technique that is really quick and easy to check your answers if you are used to your calculator. Enter the left side of the equation in y1. Enter the right side of the equation in y2. And then find where they cross. So that would be, we're going to just do zoom 6. Remember, that means the standard viewing window. And I can see right there they're crossing. Now, I can't tell what it is, zoom 6. I can't tell what it is. I have to use the calculate feature. So, second, calc. And we want to know where they intersect. Number 5. It's going to say, okay, tell me where the one curve is. Tell me where this, they call it a curve, even though it's a line. Tell me where the other curve is. And then they're going to say, put it about where you think they're crossing. So the cursor starts on one curve by default. Then it's going to jump to the next curve. Doesn't matter where. Now this one matters where. Try to get it over there, about where it looks like they're crossing. And then you're going to see, we don't care about the y value because there was no y. We care about the x coordinate. 2.6 repeated. Well, what's 8 divided by 3? Where did I get 8 over 3, by the way? That was our answer. So, if you look at our answer, we got 8/3. You can verify right there that it's 8/3. 8 divided by 3 is 2.6 repeated. So I'm going to write the steps and you can copy it down. If you want to use the calculator, enter the left in y1. When I say the left, I'm talking about the left side of the equal sign. Enter the left in y1 and the right in y2. Then zoom standard, which is Zoom 6, and you're going to second calc intersect. So that's an option you can use to check your answers. You could have just plugged 8/3 in, but there was a lot to type in, so it's up to you, to each his own. Okay, let's go to the next slide. If you have a highlighter, here's the purpose of these slides, and that's. Yeah, you're gonna want a highlighter. It'll make this stand out. Anyone need one? Toss it up. Anyone else? Good. All right. These next 2 slides are special cases. This should ring a bell. When you're solving equations, you don't always necessarily come to an answer. Look at this example. Let's start to solve it. Is there anything to simplify? No. So we're ready to start moving things to opposite sides, right? I always work with my variable term first. I'm going to add this to the left. So I'm trying to get rid of it from here. I'm going to go over here and balance it out. But what happens? That goes away. I'm left with 7 equals 17. It's a statement. You have to ask yourself, does the statement make a true or false claim? Does 7 equal 17? No. No. False statement. Which means, what? I heard it. Thought. There's no solution. Because it was a false statement, there is absolutely not a single solution that you could, not a single number that you could plug into that equation and make a true statement. All right, let's make a note. If the variable disappears and the remaining statement is false, then there is no solution. Here's what you need to highlight. If you have a false statement, it means there's no solution. Which makes sense, because look right up here. Look at the equation itself. No matter what number you plug in for x, you immediately multiply it by negative 24, right? But then on one side you add 7, and on the other side it's 17 minus what you just got. So that doesn't balance, which is why this equation has no solution. Okay? Which brings us to the next example. probably know where this is going. Looking at the equation, let's start to solve it. I'm going to add 1/3 x here to take it over to the left. But when I do that, the variable disappears, and what are you left with? So just to be consistent with what I just wrote on the other slide, does 3 equal 3? Yes or no? Yes. So this is true. Actually, let me write yes, and then I'm going to write true statement. Yes, true statement. Okay. If the variable disappears and the remaining statement is true, do you remember what the result is?
All real numbers.
Infinite. All real numbers. Any given number you pick and plug in works. And that's because the left side of the equation is identical to the right side of the equation, which is why any number works. Here is the correct terminology. Infinitely many solutions, or you need to know it all, because in my math lab they're going to have you interpret it. Infinitely many solutions, which means all real numbers, which is that big capital R, which is also negative infinity to infinity. Lots of ways to represent it. So when it's true, it means infinitely many solutions, all real numbers possible. And that's because if you look at the actual equation itself, the left side and the right side are identical. Looks like a mirror image. This is the interval notation to represent the solution set. All real numbers, negative infinity to infinity. Thank you. All right, we have 3 slides left. The next slide is, I copied it for anyone that struggles with word problems. Hopefully you're starting to learn techniques from what I tell you every time we start a word problem. The first is read through it one time. The second is to repeat reading through it, and this time omit things that you don't need, or underline or highlight things that you know are going to be important. Take notes. The third thing is sometimes sketch a picture, sometimes, or visualize being there. Okay, let's just go straight to an example. We are talking about industrial robots. Yay! Companies in China purchased 36,000 industrial robots in 2013. This is 54% more than the number of industrial robots purchased by companies in the United States. Our sources, International Federation of Robotics, Statistical Department. How many industrial robots were bought by companies in the U.S. in 2013? Do we need this? Nope, we don't need this at all. It really helps to mark out what's not necessary, because then you don't feel as overwhelmed and stressed out about the word problem. Or at least that's how I go. Do we need this? No, that's just the title. Now, we're talking about robots. We're talking about China and the U.S. buying said robots. Now you go back, you read it again and you take little notes, okay? So, companies in China bought 36,000 robots in 2013. So the way I said it was, okay, so China got 36,560 robots in 2013, right? Does the year matter?
No.
Why not? Go to the question. The question is saying how many were bought in 2013, like by the U.S. So does the year matter at all? No. So that's a number that we don't need. So that's why I'm staying with China just has 36,000 robots. Now what does matter is it says this is this. What you just read is. So I'm going to write which is 54% more than the number of industrial robots purchased by companies in the U.S. I can shrink all that down to just simply say, which is 54% more than USA. Now, I've taken those first two sentences and I have condensed it to Cliff Notes, right? And the question says, how many industrial robots were bought by companies in the United States? So, we know how many China bought. We know China bought 54% more than the U.S. Now we're going to find out how many the U.S. bought. We need a variable. When you're doing these word problems, because remember we're solving equations, you need a variable. I tend to pick the variable based on what they're telling me to find, because then it helps me remember what it stands for. So I'm going to let U equal, that's my variable, the number of robots that the U.S. bought. Hence the reason it's a U. I don't want to use R because what did China buy? Robots as well, and that's going to be confusing. You want to use something that is specific to what you're trying to find, so it will help you. It's like that one nap. Okay, so now you have to ask yourself, when you have an expression that says 54% more, China bought 36,000, which is 54% more than the U.S. Who bought more? China bought more. So imagine a bar chart. Imagine a little bar chart, right? Yes? Okay, and clearly, and be dramatic about it, because then it helps you. Don't be like, oh, it's good. Don't, just be dramatic. Who bought more? China. China bought more than the U.S., right? So if I want these to be equal, I need to add some type of value to the U.S. to make it equal. Would you agree? And we know the value because we know the discrepancy. We need to add a 54% more value here to make them equal. I'm going to put a dotted line, and then I'm going to put a question mark. Right? All right, I draw the bar chart to help you understand what I'm about to write on the board. I'm going to write it, then I'm going to explain it, and then you should be able to get there for future problems. We know China bought 36,560 robots. We know the U.S. bought some type of number. Yes? We also know the U.S. bought less. So if we want this equation to hold value, because right now it should be off balance, we're going to add a certain statistic right here based off of what they told me. I'm going to write it this way, and then I'm going to show you a condensed way, and you decide which one you like. 54% is what as a decimal? 0.54. That's one thing with word problems. If you're dealing with percents and you're going to an equation, you do have to convert it to decimal. This says right here, China bought 36,000. Then they say, which is 54% more than the U.S. So you've got to find 54% of what the U.S. bought and add it to that same statistic of the U.S. purchase, and then they'll be equal. Now look at this. What number's right here? There's an understood 1, which is why this is another way to start the problem. I've seen students start here at step 1, or I've seen students go straight to step 2 because they know that, okay, so China bought 54% more than the U.S., which means I need 100% of what the U.S. bought plus an additional 54%. What's 100% as a decimal? 1. Which is why this right here equates to, let me change pins. This equates to 154%. So you had to find 154% of the U.S. to balance it out. Okay? But now it's just solved. Like, don't overthink it. You have a number equals a number times a variable. How do you get the variable by itself? You divide. And you should get 23,740.26. Now here's the problem. Don't be technical. Can you buy 0.26 of a robot? No. You either bought the full robot or you didn't buy it at all, right? So you are going to be expected to learn how to round here based on the scenario. What makes sense? I would round down because of the 0.26. So the way I wrote it was the U.S. bought 23,740 robots. All right, look at your bar chart. You have the China amount, right? In order for these to be equal, you need the full amount that the U.S. bought plus the 54% that they're saying it was more than, which is where the 1.54 came from. You can break it apart and say, well, I need what they bought, which is 1U, and I need to add to it the 0.54. You can decide which step you want to start at. The bar chart hopefully helps you see the visual. You can even go back and now plug it in. If I plug 1.54 times 23,740 in, 36,560, I get the right answer, which is how you check it. All right, let's go to the next slide. Studying abroad. Okay, take a second, read it one time, then go back and read it and mark out what's not necessary. And let's see if we mark out the same stuff. Then go ahead and assign 2 variables. Does the
school year matter? Nope, not at all. Neither does the title. Does the source matter? Nope. By the way, when you go off into the real world after high school, if you choose to go to college, I encourage you to look into studying abroad if you have the means to do it, because everyone I know that's done it absolutely loved it. I wish I had done it. It's one of those things that it's going to be a regret. It's not really a regret, I guess. The reason I did it is because I met my husband and I didn't want to leave. But so it's sappy. I'm not doing it. I wish I had done it like when my mom was like, "Hey, there's a study abroad. You should go do it." And then the next year. Well, you can do it for there's different time spans. There's like, I think there's a month, there's 3 months, there's 6 months, there's a year. So you can do whatever you're comfortable. You're getting college credit for your gen ed classes in another country. It's not for everybody, but that's what I wish I had gone to Italy or Greece. I would have loved it.
Yeah, and then
or Costa Rica.
And then you get put on a ship container and get sent halfway across the country because
I would definitely live a little more. You've watched Taken too many times. It is a very good movie. All right. So, anyways, I was just saying, I'm just gonna put that in there, like, if you ever get the urge to study abroad, go for it. Why not? Do a small study abroad journey, maybe, and then see how you like it.
Or just take a vacation.
I know a friend of mine, she enjoyed study abroad, that she actually ended up graduating and went and taught in another country.
Can I graduate in wherever I go? Can I just graduate that way?
Oh, no, you do have to come back. Yeah. Because that's the program, like, it's an agreement between the colleges that you're over there studying, but you're going to get the credit at your U.S. college and graduate. All right. Not necessarily Google Translate right there, and there's going to be English speakers over there somewhere. You're going to find them. See, you can even go like to your school abroad. Yeah. All right, let's wrap up this problem. Okay. We've got 47,000 U.S. students studied abroad in Italy and in France. This is important. In Italy and in France. They're telling you the starts with a T, total. Then they say specifically there were 12,000 more students in Italy than in France. Find the number of U.S. students studying abroad in each individual country. With these word problems, they tend to be the same thing over and over. You've got to set some type of a variable assignment, in this case 2 variables, and then you've got to set up an equation, in this case 2 equations, and then you've got to solve it. All right, so here's what I went with. I said let I equal, where am I going with this? There you go. Number of students in Italy. Now, it is important that you use a capital I so you don't accidentally start thinking you've got imaginary numbers in your equation. We are not dealing with imaginary numbers, so I would definitely use a capital I. And then I picked what letter? F for the number of students in France. You have to be careful trying to speak the native language in, especially Europe, ladies, because especially France, the French men are like, yes, that's a great word for it. What did she said? Just ruthless. Not taken.
That's why I'm not going.
No, not taken. We were actually in London. We were eating in a truly French restaurant where they only spoke French, and the menu was in French. We thought it'd be fun.
you know, I'm like, okay, I took French in high school, and so I tried my best to recall from high school, and I think the guy thought I was trying to flirt, and at the end, like, he handed me a note as I was leaving, and it was his phone number with a sweet little message, which I still have, by the way, and my husband's totally okay with that, because I'm like, oh, he thought I was cute, you know, but I've never called him. But, so they do think, 8 years ago, do you remember handing a note to a little girl that didn't know how to speak French? But she tried. There you go. You do have to be careful. Okay.
Did he make you nervous?
Yeah, he did. He did.
Was it rich or what?
As soon as we go out to the restaurant, I'm like, I'm reading it. My mom goes, "What is that?" And I told her, I read it to her, and she goes, "Do you not have your rings on?" We were already engaged. I'm like, "Yeah, I have it on." I said, "They don't care." They do not care. They don't care. Okay. There's 2 types of equations here. I'm gonna highlight. I'm changing colors if you want to highlight what I'm about to write. We have a quantity equation. We have a quantity equation. Then we have, in this case, a value equation. Now, you might wonder what's the difference. I'm going to show you. Or you can say we have a total. Quantity could also be total. You could write the word total there. What is the total number of students abroad in this? And that's the total across how many countries? 2. So I plus F equals 47,058. Right? Now then they're giving you a specific value for Italy in relationship to France. There are 12,000 more kids in Italy than in France. Okay, bar chart. Which bar is higher? Italy's higher. So France needs to be added with the number. What number needs to be added to France to make them level? The 12,638. So Italy has more. France is off balance. We need to add the difference. You have 2 equations here. Go back to Algebra 2. There are 3 ways to solve linear equations that are called systems. There's elimination, substitution, and graphing. You want to graph when it's really ugly numbers, like decimals or like it's nonsense. That's when you want to graph and just let the calculator do it. You want to do elimination when your equations are already similar and you can just basically condense them straight down and cancel a term out. You want to use what's called substitution when you already have a value by itself and you can just come right up here and plug that in. You see it? It says right here that I is this crap. Well, where's I up here? It's right there. So plug this in there, and now you'll have an equation with only f as the variable, which means you can solve it. So we're going to solve by substitution. So I'm going to copy the quantity equation, and in place of I, I'm going to change colors. I'm going to put F plus 12,638. Now I am putting parentheses just to show that I substituted. Please don't let the parentheses make you think there's anything being multiplied. There's not. It was like plugging a hole. You're taking this expression and you're plugging it in right there. I put parentheses just to show that I was substituting it in. Now your equation has only one variable, which means you're green lighted. You can solve it. Combine like terms. Don't let the fact that it's an F throw you off. Imagine if it was an X. X plus X would be 2X. So in this case, it's going to be 2F. Bring this down. Bring this down. Now I can subtract the 12,000 to the right. And divide by 2. So how many students are in France?
17,000.
And how many in Italy? And how did you get 29,000? You just go right back to one of your equations, go to the easier one, and you just plug it into either one. Doesn't matter which one you plug it into, but let's think smarter, not harder. If I know F and I don't know I would plug it into the second one because you just add the 12,638. And that is where we're stopping today. So you need to start the 1-5 homework, and we will finish 1-5 tomorrow, which means it will be due Friday at 1 p.m.